Saxon's Trig, Lesson 23, the exponential function and sketching exponentials, beginning on page 166. In this section A, the exponential function, they take a lot of time to describe things that are not really helpful to the actual solving of the problems that they ask you to do. But they do want to do a quick reminder that exponential means I've got an exponent of some sort. So if I have a base of 3 and an exponent of 2, that's meaning 3 squared, or 3 times 3 makes 9. And those we can also call powers. So like if it's not the 2 or the 3, if it's like 4 to the 5th, we're going to say it's 4 to the 5th power. And that's going to mean 4 times 4 times 4 times 4 times 4. So once they've done that review, and they remind you that you can have exponents in an equation, so something equal to x, and then they say you can graph these things. Okay, so this is the heart of what they want to talk about in this lesson. So example 1 on page 167 says sketch the graph for y equals 2 to the x power. And I want to treat this like any other graph with the chart of picking some numbers and figuring out what it gives me. Now, I also know from experience that exponents graph curves the same as our square roots do, or cube roots, because exponents and roots are opposites. They're going to do similar things when they're graphed. So let's say I'm choosing 0, 1, and -1. Any exponent or anything that has an exponent of 0 always spits out a 1. You should remember that from algebra. 1 is the exponent, makes that 2, and then a negative exponent means I'm going to flip where that base is located so that the exponent is no longer negative, so that turns it to 1/2. Should have enough information to do the graph. 0, 1, 1, 2, and -1 graphed a fraction. So this tells me the closer I get to that x-axis, the tighter it's going to get to be 0, and this is going to go, and because it's exponents, like if I did 3 squared, I'm going to get 9. It's going to go high fairly quickly. That's what the exponent is going to graph to look like. Part B says sketching exponentials is basically the same thing. Instead of it saying y equals this, they're changing it to a function format. So f of x equals 5 to the x. How does that change it? So 0, 1, -1, anything to the 0 power, 1. 1 filled in makes that 5. And again, the negative means I need to flip it over to 1/5. The graph, 0, 1, 1, 5, and -1 fraction, super tight already. So as my base gets bigger, how did the graphs change? I got tight to the x-axis very, very quickly, and the gap here, the height goes much higher, much more quickly because the base is bigger. If the base were a fraction, the opposite would be true. It would spread way out, and this would have a wider gap here, and it would not go as tight quite so quickly. Now, example 3 tries to show you that, where it says, and they go back to y equals 0.25 to the x. Now, 0.25 is actually 1/4 to the x power. Whether you do this on the calculator or you change this over to the fraction format, it doesn't really matter. Either way, you're going to work here with 0, 1, and -1. So this is going to be anything to the 0 is 1. Exponent of 1 keeps it the same. Flip that over, that becomes a 4. 0, 1, 1 fraction, super tight, -1 to the 4. So because, I missed just a tad there, it flipped it over, and you see that the gap is not quite as tight. A little harder to see here, but my spacing's a little different between the two. But that's how these exponents are going to graph.